Well, good morning. I'm Dan Freed, Director of the Harvard CMSA. My pleasure to welcome you here this morning. The CMSA is a center here at Harvard devoted to the two-way interaction of mathematics and different sciences. We run programs, so this week started our program on mathematics and machine learning. We run workshops. We just finished an introductory workshop in that program. And we also run conferences. So Big Data Conference has been running since the beginning of CMSA. This is the 10th version of Big Data. So we're very happy to have that. We also have quite a few postdocs, and they run weekly seminars. We have visitors, lots of activities. You can find out more online, but you didn't come to hear me, so I'll pass it over to Morgan.
Okay, hi everyone. I'm going to introduce our first speaker, Peter Hall, who is a professor at Brown University of Economics, and he's also a faculty research fellow at the National Bureau of Economic Research. He did his PhD at MIT, his postdoc at Microsoft Research New England, which I'm biased towards too. Also did my postdoc, and he's an assistant professor. He was an assistant professor at University of Chicago before going to Brown University. He is an editor of the Review of Economics and Statistics, and his work mostly focuses on applied econometrics, crime, discrimination, foster care, etc. And he's visiting MIT for a year. Right. So if you have good interaction, he's around, and you can talk to him throughout. Want to take it?
Wonderful. Well, thanks so much for that very kind introduction, and thanks everybody for being here. Thanks for having me. It's fun to present work to non-economists from time to time, get a little bit of outside perspective. I am used to presenting to economists, and those who might know this, economists like to interrupt talks throughout with questions, and so please feel free to interrupt with questions or comments as I'm going, especially clarifying things if something is not clear. I recognize that there might be sort of language barrier differences in terms of the jargon that I'm using versus things that others might be used to thinking about. So please don't hesitate to let me know if there's something I can clarify. So I want to talk to you today about some work that we've been doing on measuring discrimination in complex systems, particularly multi-phase systems. So systems with multiple decision makers sort of making decisions in sequence or simultaneously, and thinking about how inequality sort of arises and perpetuates through these systems. So we've been doing this in a number of different settings. I'm going to talk to you today about an application to foster care, to child protection. And so this is building on a recent paper with these great co-authors, some of whom are nearby. And it was recently published in the Quarterly Journal of Economics. If you're interested, you can take a look to see much more on what I'm about to tell you. So we have an hour. Is that right? Okay, great. So let me start by just setting things up, motivating what we're doing here. This first bullet is probably, I don't even need to say it, but as motivation, it's useful just to start us off. So obviously, discrimination is a big concern these days in a variety of settings. There are large disparities by race or gender or other sort of protected characteristics in a variety of high stakes settings. And this has raised concerns about discrimination in economics, at least, and I think in a lot of other fields. When we talk about discrimination, when we think about inequality, the focus tends to be on individual decision makers. So we think about like the bias of a particular judge in a crime context or of a doctor in a healthcare context. We think about individuals sort of introducing bias or introducing discrimination in decisions. But especially outside of economics and say computer science or in sociology or in other settings, this kind of growing understanding that this focus on individual bias, on individual discrimination can yield a sort of incomplete picture, because most high stakes decisions don't just happen with one person kind of pressing a button. It happens with multiple people making decisions over time or in a particular system or in different settings. And that can lead to inequality kind of arising and compounding and changing in potentially complex ways. And so that's kind of the motivation for this work. Of course, it's very straightforward, at least these days. There's a lot of frameworks for sort of thinking about this in theory, thinking about how inequality can arise, especially with the recent literature on algorithmic fairness in computer science. There's a lot of work thinking about how systems can sort of perpetuate and increase inequality. But I would say that bringing this kind of analysis, this theoretical framework to data is usually very hard. So what I'm going to call this like systems-based analysis of discrimination, it's hard for at least two reasons. One is purely a data reason. So, in order to study how inequality sort of interacts through a system, well, we at least need a data set that lets us do that. So we need data that sort of follows people through their interactions throughout a system. Those data are not often easy to get, although we have increasingly some settings where we can actually track individual decisions and see how individuals move throughout a system. The harder problem from a sort of statistical perspective, from a econometric perspective, the one that we're going to spend more time on conceptually today, is a problem that as economists we tend to call omitted variable bias, right? So when we think about disparities, of course, you can see in the data relatively easily, say, racial disparities in particular decisions, but we wonder whether those disparities reflect discrimination or just factors that are relevant for the decision and potentially correlated with race that we as the statisticians don't observe in the data. And so adjusting for those omitted variables, adjusting for that kind of background measures that we don't see becomes very crucial for when we start talking about discrimination. And so that's going to be kind of what we're focusing on from a methodological perspective in this work. So that's the pitch. That's the sort of setup for what I'm going to tell you about for the next 55 minutes or so. We are going to develop what we call in economics quasi-experimental methods for overcoming this OVB issue, for dealing with the fact that we don't observe kind of relevant characteristics for all individuals in the data. And I'll tell you much more about that in a few slides. But then I'm going to focus on developing these tools and applying them in the context of foster care. So let me start, before I tell you about what we actually do from a more data statistical perspective, let me tell you a little bit about the child protection system in the US, in case you're not familiar, because this is going to be where we develop most of these tools. So CPS, Child Protective Services, their job, their mandate under the law is to investigate reported cases of child maltreatment, so that's abuse or neglect in the home. And they investigate it. They do a bunch of things to determine basically whether the risk of future maltreatment in the home is high. So they get a call from a mandated reporter, maybe a teacher, maybe a family friend, or some concern that there's some form of abuse or neglect of a child in a home. And then as I'll show you, there's sort of various steps that they take to intervene given those reports. But their main objective is to sort of determine whether that call is substantiated, whether the risk of maltreatment in the home is high. And then, this is obviously a very high stakes decision. It's a decision that can have very important consequences. If they determine that the risk of future maltreatment is high, they might place children into foster care. So they might remove them temporarily from the home. There's a large literature, of course, in economics, but also outside of it, studying the effects of that decision to put kids into foster care. Suffice to say, it has a number of long-term effects, some positive, some negative, very different across different populations, and it has effects on both children and families. So it's a very important. Obviously, you can imagine a very serious decision. Now, in practice, these next set of stats that I'm going to show you were very surprising to me when I started working on child protection. In practice, contact with CPS is higher than you think. The rate of contact is higher than you think. It's more common than you might think, and it's also very unequal by race. So
are these national, the US?
These are national statistics, yeah. So these two papers study sort of overall rates of CPS contact. 28%, almost a third of white children in the United States experience some contact and investigation with CPS by the time they reach adulthood. So that's huge. Yeah.
Just a quick question. What triggers an investigation? Or how does that
there's two main routes. One is that there are mandated reporters. So there are people who are sort of trained to recognize signs of abuse and neglect. Largely, these are teachers or law enforcement. A large share of referrals come from them, but there's also just hotlines, and anyone can call those hotlines and say, I think that my neighbor is being abused, et cetera. So they come from all over, basically. So a third of white children experience an investigation by adulthood. For Black children, it's half. Half of all Black children in the United States have some contact with CPS by the age of 18. Now, contact doesn't mean removal from home, right? So contact might just mean someone shows up at your house and says, hey, let me take a look around, let me talk to you, is everything okay here? But even if we look at foster care, so actually like removing a kid from the home, 1 in 10 Black children are removed from the home, at least temporarily, by age 18. For white children, it's 1 in 20. So these are very high rates of intervention, and also very disparate rates of intervention, which, per the previous slide, kind of motivates this concern about discrimination. And indeed, there's a lot of sort of popular press or policy discussions about the possibility of discrimination motivated by these kinds of racial disparities. So here's just a recent sample of that from a couple, organizations you might have heard of and some maybe not: the American Bar Association, the New York Times, and the UN. So, there's basically, because of these disparities, there's this concern that maybe the system is racist, or at least sort of racially discriminatory in sort of separating Black families at higher rates than white families. There's a sort of long history of family separation being racially disparate in the United States. But of course, per what I was saying on the first slide about omitted variable bias, it's not so straightforward to immediately infer from these statistics that there is racial discrimination. Of course, if there is racial discrimination, that could be very consequential, given the things I told you about how high stakes this decision is. But the disparities that we see might just reflect differences in need, underlying differences in the risk of future maltreatment in the home. It could be that for a variety of reasons, maybe reasons related to racial discrimination in other settings, but it could be for a variety of reasons that Black children face higher risks of maltreatment in the home, and that is consistent. That's the reason why they are removed at a higher rate. So that's the key sort of omitted variable challenge that we're going to try and study here. How do we decide or understand how much of these sorts of disparities are driven by sort of true differences in risk of maltreatment in the home versus those which are unexplained by that, which we can kind of attribute to some form of discrimination. Now, the question was asked before about how these referrals actually come in. So what's crucial for our analysis of this, and this is kind of getting back to the original point about multi-phase systems, is that when these decisions are made, they're not just sort of made in one shot, they're made across at least 2 phases of the CPS system. Calls come in, again, through, say, a hotline or through a mandated reporter. Those calls get passed to a call screener in most contexts. The screeners then decide basically whether or not to open a case, whether to launch an investigation. That's called screening in a call. Or they might screen out a call. They might determine that, well, it's not really sort of a credible call, or I don't think it's worth an investigation here. These statistics here that I'm showing you, these are from our data, which is not nationwide. It's just studying the state of Michigan, which is where we have our data. 40% of calls that come into the hotline in Michigan get screened out in that initial phase. The remaining 60% get launched as an investigation. Those calls get passed to a different decision maker, an investigator. The investigator then goes to great extents to determine whether there is, in fact, a high risk of future maltreatment in the home. They might interview family members. They might look at health records or school records or crime records. They take a very deep dive over about a month to decide whether or not to intervene. And the most common form of intervention, or at least the most consequential form of intervention, is removing a child from home. But it's not actually that common, luckily. So the rates of foster care placement have come down quite a bit in recent years. Only about 3% of calls in our data end up in family separation. Yeah.
Quick question, are these figures for the first time callers or are these also including the repeat callers?
These are including repeat callers. So I'll show you some summary statistics of our data a little later on, but most children in our data are first times, but there are of course repeat spells. This is averaging over both of those. Yeah.
Do you have like do you know what the rate at which different demographics are called in, right? Because I know you're going to talk about the
Yes.
later portions.
Yes. We do. So we definitely know the racial shares of initial calls. We are going to condition on the initial calls in our analysis. Ideally, we would like to also study the process at which people enter the system, but we don't really have data before then. So we're kind of taking a first step in, usually when we study discrimination, at least in economics, we sort of focus on this single phase, and we're sort of taking a first step of unpacking things a little bit further in the system, but there's kind of a limit we have to stop somewhere. So I'm not gonna be able to tell you much about selection into the system. Yeah.
Does your study go into any data about backgrounds of the screeners and investigators? Who, in some way contribute to this discrimination?
Yes, so we know some things about the screeners and investigators, so we know their basic demographics, we know some things about their experience levels, but we have relatively limited data on, their qualifications or their training, and so we don't say as much on that as I would like, but I will show you some things about heterogeneity across these different decision makers. Any other questions at this point? Okay, so this is the sort of multi-phase system. It's a simple system, right? It's only 2 phases, but as I said before, it's kind of a first step towards developing these tools, which might hopefully let us go further in the future. So as I mentioned, we have data from Michigan. We have very rich administrative data from Michigan that lets us track kids through both phases of the system. So solving that sort of first data problem I highlighted. To solve the second omitted variables bias problem, we're going to use the fact that at both of these phases, at both the screening phase and the investigation phase, the decision maker who gets assigned to a case is basically assigned by lottery. There's some complications there, but more or less there's some randomness in who gets assigned, both when a call initially comes in and when a call gets assigned to an investigator. And that randomness, that sort of experimental or quasi-experimental variation is going to be our main lever for dealing with this omitted variable bias challenge. And I'll show you exactly how in a few slides. But that's kind of our insight here, is that we can use, as we do often in economics and in other fields, use that as good as random assignment to deal with omitted variable bias. So in a nutshell, what we do in this paper, we first are going to develop some tools which let us use that quasi-random assignment to address OVB and measure discrimination in both phases of the system. So we can look at what we're going to call unwarranted racial disparity or discrimination, both among screeners and among investigators. That's kind of the classic, individual level decision-making analysis that we might see in other papers. But then the next step is to really show how we can combine those estimates to study the system as a whole and see how discrimination arises and propagates through those 2 phases of the system. So that's the sort of framework that we're bringing in this paper. And of course, I'm going to develop this in the context of foster care, but hopefully you're already starting to think about other settings where this might be useful. You might think about police and judges in a criminal justice setting, or triagers and doctors in a healthcare setting, or decision makers and algorithmic guidance processes in a sort of human in the loop, algorithmic setting. Hopefully there's other settings like this where these sorts of tools might be useful. Substantively, if you are interested in this foster care setting in particular, and hopefully I've motivated at least some interest in that, what do we find? Well, we find that there is indeed unwarranted racial disparity, unwarranted disparity. That's our sort of measure of discrimination, which I'll formalize in a second, in the sense that calls involving Black children in Michigan in this data set are 55% more likely to result in foster care placement than calls involving white children, conditional on their true maltreatment potential. So conditional on their risk of abuse or neglect in the home. So in other words, the disparities I showed you before are not explained by differences in risk. They're not fully explained by differences in risk. There's a large unwarranted disparity conditional on the sort of objective of the child protection system. So that's sort of the overall level of discrimination in the system. In terms of the sort of two phases of the system, we show that there's meaningful sort of discrimination coming at both phases. Screeners account for almost a fifth of the total unwarranted disparity, even though they sort of act in this initial phase. They are very important for this ultimate level of discrimination. And there's also some very interesting heterogeneity here, which is revealed by our framework. So this level of unwarranted disparity, it turns out, is concentrated in cases where there is a high risk of future maltreatment. And I'll get into the interpretation of that a little bit later. But basically what that suggests is that there's a potential underplacement actually of white children, because Black children are being removed at a higher rate than white children, but it's mostly in cases where there's actual like high risk of future maltreatment. If we think that foster care is helpful in those cases, we have some evidence for, it actually suggests that maybe we should be removing white children at a higher rate. Yeah.
What do you mean by true maltreatment potential?
Yes, so I'll get into that in a second. In practice, we're going to use a proxy because we don't actually, go in and measure that. So what we're going to use is future referrals for maltreatment as our proxy.
In the same home.
In the same home, yep. And so you can tell stories about why that's not a very good proxy. It's subject to the same sort of biases, especially the biases of who gets initially reported. So we do a lot of work in the paper to sort of look at different proxies, some that are more upstream or less upstream. We find very robust results. I'm not going to have so much to say about that today in the interest of time, but it's a very important part of this analysis, so I'm happy to talk more about it. So that's the paper in a nutshell. Any questions before jumping into this? Any other clarifying questions before jumping into this? Okay. So next 40 minutes or so, I'm going to start by just sort of outlining the statistical approach that we use in this paper, sort of how we can use that quasi-random assignment of decision makers to overcome admitted variable bias. That's going to be kind of the abstract sort of methodological part of this paper. I'll then show you what we actually get when we apply those methods to the foster care system, and then. So to start, and I already sort of mentioned this, but now let's do it a little bit more formally. We have to define discrimination. Obviously there's many ways to define discrimination, bias, or inequality. So we have to take a stand on what exactly we mean. And I've already sort of told you that what we mean is basically unwarranted disparity. So this uses the fact that the CPS mandate is to intervene with children when there's a high potential for their future maltreatment in the home. That's going to motivate unwarranted disparity, which are disparities by race in various intervention rates, conditional on, quote, true maltreatment potential, subject to the point about proxies that I was just talking about. So the idealized measure in this context is I take two children and I somehow go into the home and I determine the true sort of potential for maltreatment 6 months later. And then I condition on that and I look at the disparities in foster care removal rates on average for white children versus Black children with the same potential. And so that is a measure which has some precedence. So folks here who are familiar with the sort of algorithmic discrimination literature, it's very closely related to this notion of equalized odds, right? We're sort of conditioning on the true sort of thing we're trying to predict and looking at the classification rates, disparities by race. That's the sort of idea here. We made the argument in earlier work that this is linked to the legal theory of disparate impact. And we can sort of also link it to various theories of discrimination in economics. So for folks who are familiar with this idea of statistical or taste-based discrimination, this measure sort of encapsulates both of those, as well as indirect discrimination, or what's sometimes called systemic discrimination in the literature. So it's a very broad measure of discrimination. I'm happy to talk more about it, but that's our measure for the purposes of this analysis. Now, to this very important point about we don't actually go in and measure true maltreatment potential, that's sort of impossible. we're gonna have to pick a proxy. And the proxy that we pick sort of follows the child welfare literature. When they think about risk of maltreatment, they usually think about it as like, you know, a mistake that was made by the investigators, in the sense that the investigators don't remove a child from the home, and then 6 months later we see another reinvestigation for maltreatment in the home. 6 months is kind of arbitrary. We can pick 3 months or 12 months, and again, we sort of show robustness to those different horizons. Reinvestigation is obviously not maltreatment itself, and so we can look at other proxies like re-referral or re-removal. That's sort of the most extreme version, is that 6 months later a kid was left in the home, and then 6 months later they are actually removed for maltreatment. All of those give very similar results to what I'm about to show you, so I'm going to focus on this main proxy, but again, happy to chat about that offline. So the key problem here, the key sort of identification problem or measurement problem in this context is that, well, for the kids who are not removed from home, for the kids who are left at home, we observe this proxy directly, right? We get to see whether, because we have this linked data, we get to follow kids over time, and we get to see whether there's a future reinvestigation. And so for those kids, we can determine whether there is kind of this potential for maltreatment given this proxy. But for the kids who are actually removed from home, we don't know what would have happened to them had they been left at home. So this outcome that we want to sort of condition on to measure unwarranted disparity is selectively observed. And that's the key measurement problem.
How many kids who are placed in foster care eventually are reunited with their parents? Because you could imagine.
Most, yeah.
So you could imagine getting that observation, right? Like, I guess there's a question of like how permanent risk is, but.
So we think of the CPS decision to remove a kid from home as helping the home environment, right? Like, it's a very serious decision, sort of shocks the family into maybe making some changes. CPS also supports the family during this time to give them additional resources, training. So I think that might not be a good proxy, because we think that there are kind of direct effects on that outcome, but we do actually look at that in one of the analyses of this paper. I forget what we find actually in that robustness check, but it's a good idea. So this is the sort of omitted variable bias problem, or the selection problem here. We want to kind of condition on this outcome to measure unwarranted disparity, but we can't actually do that because we only see it for a subset of the data. Now, you might already be thinking, well, it's a subset of the data, but it's actually the majority, because only like 5%, 3% of kids are removed from home. So that's actually true, and that's going to help us a lot in this context, because we have a selection problem that's not super serious, and that's going to help us a lot when we sort of use these quasi-experimental methods to overcome it. Okay, so very formally, I have to, I'm here, so I have to show you some math. So this is the sort of mathematical notation, mathematical formalization of the words I just gave you on the previous slide. We're going to measure discrimination by unwarranted disparity. That's this delta thing here. We're going to first measure it for the screener decisions. It's just going to be the difference in mean screen-in rates by race, conditional on this proxy for maltreatment potential, whether a kid would be reinvestigated 6 months later. You'll notice that, because we're conditioning on this sort of maltreatment potential, this potential outcome, if you want to think of it that way, there's actually two types of unwarranted disparity. There's the disparity among children who would not experience future maltreatment 6 months later, that's delta S0, as well as the UD among kids who would experience future maltreatment, that's delta S1. So we're going to separate those out and study them individually to try and look at sort of the heterogeneity here. But that's kind of the two forms of discrimination we can measure in screener decisions. And then, of course, we can average them together to get a sort of summary measure. That's what I'm going to focus on. So the summary measure just takes the sort of weighted average of these two deltas by the overall rate in Y star. And so our goal is to estimate those three things. Of course, the problem, as I just showed you on the previous slide, is that, well, we can't actually estimate these disparities by sort of sample means, because we only observe Y star among the kids who are actually left at home. So that's for screeners. Things follow very similarly for the second phase of the system for investigators. So there we're going to we're going to look at the kids who are actually screened in. So the kids who actually make it to the investigation phase, but then we're going to similarly condition on maltreatment potential and compare now the placement rates, so the rates at which kids are removed from the home, again by race. And so just as before, we have sort of two forms of UD, high risk, you can think of it as high risk and low risk, or kids with maltreatment potential, without maltreatment potential. And as a summary, we're going to sort of average those together. Our goal again is to estimate those three things, and our problem again is that we only observe Y star selectively. Okay. And then the final piece here, we sort of look, so I'm going to estimate those. I'm going to tell you how we overcome that problem to estimate the screener and the investigator disparity separately. We can also think about the overall unwarranted disparity in the system. As kids are sort of entering the system, what's the overall disparity in placement rates by race conditional on Y star? That's this delta P. And we can again define sort of the average delta P here. And then we can do a decomposition, so we can decompose this overall placement unwarranted disparity into a component that's sort of driven by the UD of screeners and a component that's driven by the UD of investigators. So that's our decomposition. That's where the 20% I told you before comes from. So we're going to estimate overall unwarranted disparity, and then we're going to say, about 20% of it comes from this component, about 80% of it comes from this component. But that's sort of jumping the gun a little bit in terms of what our findings are. Any questions so far? Okay. All right, so how do we actually overcome this challenge, right? So we can't directly estimate these. The trick that we're going to use is basically to rewrite the terms in these delta. I'm going to show you it for screeners because the math is a little bit simpler. We're going to rewrite the terms underlying these deltas into a set of components, some of which we can actually directly estimate in the data, and some of which we have to do some sort of fancy econometrics to estimate. So here's that decomposition of these terms. So again, for our unwarranted disparities are basically differences in these things by race for Y star equals 1 and Y star equals 0. This is just using the fact that S and Y star are binary. You can trust me on this algebra, or maybe you guys are smart, you can already see it in your heads, but these two expressions are equivalent. The key point here is that the numerators of these expressions we can directly estimate. The reason for that is that we see this maltreatment potential Y star if a child is left at home. So if S equals 0, if they're not screened in, then we know for sure that they're left at home. And so these two terms, there's no sort of selection problem. Whenever S is 0, we get to see Y star. So that whenever S is 0, this is 1, right? And we get to see Y star. When S is 1, we don't get to see Y star, but that doesn't matter because we know that numerator is 0. Okay, so the point of this sort of algebra is just that, well, we've simplified the problem now. We know that in order to estimate these measures of unwarranted disparity, we just need to estimate the denominators because we know we can get the numerators easily. What are the denominators? The denominators are simply race-specific maltreatment risk. So the probability that Y star equals 1 by race, those are the key parameters that we need to estimate in order to complete this expression. And again, the reason why those parameters are hard to estimate is that we don't observe Y star for everybody, we just observe them for the subset of people for which S equals 0. That said, most kids are left at home, most kids have S equals 0, so the selection problem for this is not that dire. And that's how we're going to sort of make progress here.
Although we presumably imagine that the treatment risk is higher amongst those who are.
Indeed. So I'm not going to talk about this, but in the paper we start by just putting some bounds, right? So we can bound this very easily because again, Y star is binary. We know the share of people who are removed, and so we can do sort of non-parametric bounds. We can also do what you're saying, which is say, well, we can improve on 0-1 bounds by assuming that the people who are removed from home are actually truly of higher risk, or at least not of lower risk. And so in the paper we do that. I'm going to skip over that just in the interest of time, but those bounds are very precise. Any other questions here on this item? Okay, so how do we actually estimate these? We are going to use a version of what's called in economics identification at infinity. And this is where the random assignment of screeners and investigators helps us. To set up this approach, I want you to imagine that there is some screener out there who doesn't take any calls seriously. They don't really believe that any calls contain sort of maltreatment potential. And so they basically screen out all calls. Now, there is no screener like that in practice, but imagine that there was a sort of supremely dismissive screener. Because we have random assignment, we could just look at the calls which were randomly assigned to that screener. We know that that screener screens out all calls. And so we would see the Y star for all of the calls that were assigned to that screener. And we know by random assignment that that mean sort of Y star is representative of all calls because it's of course just a random subsample. So if we had a screener who screened everybody out, then we have identification of these key parameters that I showed you on the previous slide just from the randomization in the system. Now in practice, as I said, we don't have that kind of supremely dismissive screener, thankfully, right? That would be pretty dangerous. But what we do have is screeners who vary in their screening in and screening out rates. We also know that screeners have pretty low screen in rates overall. And so what we can do instead is look across randomly assigned screeners, look at how the sort of Y star rate varies as we look towards more dismissive screeners who tend to screen out more calls. And we can use that variation, that quasi-experimental variation, to make our best guess at this mean Y star by basically extrapolating that variation. This is going to work well because there's low placement rates in CPS, and so we don't actually have to do that much extrapolation. And we can sort of visualize it, we can assess whether we sort of buy the extrapolation based on the data. So this is the kind of approach. Let me show you it visually, but I'm setting this up for the screener case, but you could imagine how this kind of also extends for the quasi-random assignment of investigators. So visually, here's what's going on. If we look across different screeners, so each dot here is a screener, what we would want to know is what is the subsequent maltreatment rate of calls that are assigned to our sort of supremely dismissive screener who screens out all calls, therefore has no foster care placement among calls assigned to them. That's that green dot there. So that's what we want to know. Of course, we don't see that green dot, but we do see screeners with very low placement rates, and we see some variation across them. And so what we're basically going to do is take those blue dots we actually observe, and we're just going to fit a line or a curve, different ways you could sort of extrapolate that variation, and basically use the intercept of that line as our estimate of that key parameter. And of course, we're going to do this separately by race, and that's going to give us the two mu r, the two risk parameters that we need to complete that formula. So that's the basic idea. As I mentioned, so first of all, you can see from this a couple of things. First of all, there's different ways you could do this extrapolation, right? So you could fit a line, you could do quadratic, you could do a non-parametric sort of local linear extrapolation if you have rich enough data near zero. And so we do a bunch of variety of different extrapolations to show robustness to that. You could also form bounds per the conversation we were having before. If you didn't want to take any extrapolation, well, you know some things about mu r even without drawing these lines, because these points kind of give you variation in those bounds. So you can do that instead. So all that to say, it's a very flexible approach for overcoming this OVB challenge. And it's also one you can sort of visualize. So you can get a sense of how much the data is telling you what these parameters are versus how much work you have to do statistically to extrapolate out of sample. Okay, so this is fake. This is not real data. It looks really good. The real data doesn't look this good. I'll show you it in a second, but this is kind of meant to sort of illustrate the approach conceptually. So now let's talk real data. Any questions on the approach? Okay, so real data time. As I mentioned, we have data from Michigan. So this is Child Protective Services in Michigan. We see all of the hotline calls, all of the screening decisions, all of the investigation decisions from 2008 to 2019. So we stop it just before the pandemic because things get a little weird during the pandemic, as I'm sure you can imagine. We're going to use quasi-random assignment of screeners. So the way that this works is there's 2 call centers in the state of Michigan. And when you call the hotline or when you make a mandated report, you get sort of randomly assigned to one of those 2 call centers. And then you get randomly assigned within those call centers to a screener, basically on a sort of first come, first serve rotational basis. So it's a very straightforward kind of randomization process. We have to condition on a couple of things which are not random in this process, but we have very clear randomization condition on those things. For investigators, it's a little more complicated because it's not like a automated call center. It's sort of an office where human investigators get sort of assigned different screened in cases. But again, it's sort of a rotational process where it's more or less first come, first serve. Whoever has waited the longest since their last investigation gets assigned the new case. And so in the paper, we have a variety of empirical tests of the random assignment, which seem to work well. Our main analysis sample has, again, about 200,000 calls, about 800 investigators. We restrict to investigators that see at least 200 cases to avoid some like finite sample, small sample issues. And we have 162 screeners. So a large number of decision makers. The overall screen-in rate is about 60%. I showed you that on that first graphic. That is racially disparate. So 63% of Black children get screened in, 59% of, white children get screened in. So we see disparities already in the first half of that graph. And then I also showed you the 3.4% placement rate among screened in calls. That is also racially disparate. So here's a little more detail in terms of the sample, probably more detail than you want to see. So this is just summarizing some basic characteristics of the child, basic characteristics of the call. We have much more of the sort of call characteristics and child characteristics in the paper. Panel C, these are the treatment rates that I was mentioning on the previous slide. So the racial disparity in the screen-in rate, the racial disparity in the placement rate conditional on being screened. And then the new piece of information that I'm showing you in the sample is the outcomes of children if they're not placed. So among the kids who are left at home, again, we get to see whether they were reinvestigated within 6 months. So overall, unconditional of anything, about 14% of kids are reinvestigated within 6 months. There's a racial disparity in that sort of overall Y-star measure. But what's kind of interesting here is that it might not go the way that you expect. So it turns out that white children actually are at a higher risk of future maltreatment, if not placed, than Black children. So white children have about a 14% percentage point risk of future or proxy of future maltreatment. For Black children, it's 13 percentage points. If you think back to when I was first sort of motivating this, the motivation was like, well, maybe Black children face a higher risk of maltreatment in the home, and so there's a higher need for intervention, and that's what explains the racial disparities. But it turns out to not be the case here. If anything, it goes the other way. And so what that suggests is that, well, maybe, in fact, these disparities that we see, these raw disparities that we see, understate the true level of unwarranted disparity. You would think that if the Black rate were higher than the white rate, we could shrink this gap a little bit by accounting for that differences in risk. But if anything, it seems to go the other way. Now, the caveat to that, of course, is that we only observe the outcomes among kids who are actually left at home. But the caveat to that caveat is that that's the vast majority of kids in our data. So that indeed seems to be, that's going to bear out in the results that I'm about to show you. So that's the analysis sample in this study. Here's the sort of actual version of those extrapolation plots. Again, it's messier than the nice clean version I was showing you before, but it's not too bad. So we have a pretty stable relationship in both the screening phase and the investigation phase, a pretty stable relationship in the maltreatment rates by placement rates across different decision makers. And we see, just like in that previous table, white children tend to systematically have higher Y star than Black children. There's a bit of a slope, which is what you would expect if you think that screeners and investigators are sort of making smart decisions. as they screen in more and more kids, or as they place more and more kids, the rate of Y star declines. That would make sense if they're sort of ordering them by Y star. And so basically, we're going to use the intercept of that relationship at 0, like I was showing you before, as our estimate of these mu parameters, and then plug those into the formulas to estimate discrimination. And you can see how we do this linearly, this extrapolation linearly. We have a more flexible quadratic or a local linear regression here, but those are all going to give roughly the same intercept. And so the key point is that we have a higher maltreatment risk actually for white children versus black children, and that's going to suggest not that the raw disparities are sort of biased upwards, they overstate the unwarranted disparity in the system, but they actually understate it. So these are the main estimates for unwarranted disparity in Michigan CPS. So the top is just showing you our estimates of those intercepts. So the mean risk parameters by race, you can see that if we get very precise estimates there because we have a lot of data. Panel B, that's our measure of sort of average unwarranted disparity, both for screeners and for investigators. So for screeners, it's about a 5 percentage point disparity. I think on the previous slide, it was like a 4 percentage point raw disparity. So it's a 1 percentage point higher disparity when we account for differences in risk. For investigators, conditional on being screened in, they remove black children from the home at a 1.7 percentage point higher rate than white children with identical maltreatment potential, or at least our proxy for it. I think in the raw disparity, it was like 1.4 percentage points. So again, a little bit larger. So the bottom line is that there is unwarranted disparity at both phases of the system. It's larger than you would think if you were just looking at the raw gaps, because mean risk is higher for white children. And then in the final panel here, we do that decomposition I was showing you. So we can look at the overall. We have 2 ways of doing this decomposition. Usually folks who are familiar with this kind of Kitagawa-Owaka blinder decompositions, you know that there's like multiple ways of doing it, different orders, and the order sometimes matters. So technically there's 2 decompositions that we look at. They both give very similar results. The overall unwarranted disparity in the system as a whole is 1.1 percentage points. And between 13 and 19% of that overall disparity comes from that initial screener decision. And so even though a relatively small share of screened in kids are actually placed into foster care, so that you might think from that the screener decision doesn't matter that much, it turns out to matter a non-trivial amount. And that sort of highlights the importance of studying both parts of the system in this setting. Okay, so those are our main results. Hopefully it's relatively clear how we got there and relatively credible. Let me now unpack these results a little bit, sort of to show you what this machinery can actually do beyond this sort of overall estimate of discrimination. Well, one thing we can do is we can look separately by maltreatment potential. So these are the sort of averages across kids who do have potential for maltreatment and kids who don't have potential for maltreatment. Let's now break these apart into those 2 delta 1 and delta S components I was telling you before. So the weighted average, that's what I was showing you before in column 1. Columns 2 and 3 are doing the same sort of analysis separately for with and without maltreatment potential. A couple things kind of pop out here that I think are sort of interesting. First of all, at the first stage of the system for screeners, call screeners, they tend to screen in Black children at a higher rate than white children, conditional on maltreatment potential, for both kids with and without maltreatment potential, so both high risk and low risk cases. So they don't seem to really be distinguishing between those so much when it comes to discrimination. At the investigator phase, however, it's very different. So at the investigator phase, the vast majority of unwarranted disparity comes from cases with maltreatment potential. And partly that's because it turns out investigators remove a very small share of kids without maltreatment potential. So they seem to be pretty good at their job. They seem to be pretty good at distinguishing the cases that are actually high risk versus low risk. There is a little bit of a disparity among the cases without maltreatment potential, but it's not statistically significant. So I should have mentioned this before in case you're not used to seeing this format of tables. These are standard errors. So this is not a statistically significant disparity, but it is significant and much larger actually than the overall in the case with maltreatment potential. Yeah.
I apologize if you already covered this.
No, yeah.
For screeners,
Mm-hmm.
do they have kind of perfect information as to the race of the New child?
No, this is a great question, actually, and I didn't talk about this. So where does the information in race come from? At the screen-in phase, for the vast majority of calls that come in, what the screener sees is a database linked to the phone number of the incoming call that links it to basically public welfare programs in the state. So things like preschool or like food stamps or like other things like that. They also link to educational records, and that's where the racial information comes from. So it comes from other administrative data sets.
So the assumption is that they know. The assumption is that the screener knows.
They know at least, you know, the race that's encoded in those data sets. Yes. Investigators, of course, see the child, they see the parent. And so we actually have some follow-up work studying sort of what you might call miscoding of race or like differential coding of race by the investigators versus the screeners. It's a really interesting question. But for this, we're just going to take basically the race that's coded that the screeners see as our measure. Yeah, no, it's a great question. So screeners basically don't seem to be as good at differentiating high and low maltreatment cases, and that partly influences the fact that they have equally large unwarranted disparities for both groups of individuals. Investigators seem to place a very small share of kids without maltreatment potential, and so most of their unwarranted disparity is coming from cases with maltreatment potential. And so what that means in effect is that overall, if you look at the system as a whole, most of the unwarranted disparity is coming from cases with maltreatment potential. And so basically the investigators are sort of attenuating the unwarranted disparities that the screeners interject into the system among cases without maltreatment potential, but they are actually amplifying the discrimination that arises among cases with maltreatment potential. And so that the other piece of the puzzle here, and then I'll talk about how to interpret that. And this gets to a question before about screener investigator characteristics. So one thing we can measure really well in the data is investigator race. If we look at the unwarranted disparities separately by investigator race, we see a kind of interesting pattern. White investigators, those tend to be the ones that place Black children at a higher rate than white children, conditional on maltreatment potential. But for Black investigators, it actually goes the other way. For Black investigators, they actually place white children at a higher rate than Black children, conditional on maltreatment potential. And so in other words, there's a kind of racial concordance pattern here, which one interpretation of that is basically that investigators are giving more of a benefit of the doubt to parents that share their race. So white investigators are sort of giving more of a benefit of a doubt to white families, white parents. Black investigators are sort of giving more of a benefit of doubt to Black families. That's one interpretation of this result. Obviously, you could give others as well. And so putting these two pieces together, putting together this fact and the fact that most of the unwarranted disparity is coming from cases with maltreatment potential, that leads to sort of the implication I was hinting at before about the potential underplacement of white children in this context. So in most of these policy discussions about racial disparities in foster care, the main concern is overplacement of Black children, which is not surprising given the long history of racial family separation in the United States and concerns about basically Black children being removed from their home at an unfairly high rate relative to white children. But what we find is that this placement unwarranted disparity, sort of conditional on true maltreatment potential, tends to be driven by higher risk cases, tends to be driven by white investigators potentially giving the benefit of the doubt to white families. And we know from other work that foster care is very beneficial in this population, particularly in high risk cases. So removing a kid from home when they're in a very risky home environment, not surprisingly, is very helpful for that kid's long-term outcomes. And so putting these pieces together, it suggests a potential underplacement of white children from these high-risk environments. And potentially that's coming from, counterintuitively, white investigators giving white families disproportionate leniency. So the white investigators are giving white families the benefit of the doubt, but that actually turns out to be hurting their children because it's leading to worse long-run outcomes if you think that they should be actually removed from home at higher rates. And so we do some sort of counterfactual simulations of this in the paper, and some more stuff which I don't have time to talk about today, where we can show that if we sort of address these kinds of unwarranted disparities, equalize sort of the placement rates conditional on maltreatment potential, it would actually increase subsequent maltreatment for Black children by about 7%. So that's kind of consistent with this potential for underplacement. So this is one take on this. I think it's certainly not the narrative or the result that we were expecting going into this project, but I think it adds some interesting nuance to those sorts of policy discussions. So in the last couple of minutes, let me just tell you a few other things that are in the paper if you're curious. Many of these I've already mentioned. So one is that we do a lot of work looking at robustness to other proxies of maltreatment potential. That's like a key input into this analysis. We find very similar results. Kind of surprisingly, we don't find a lot of heterogeneity by child characteristics, so like age, whether the mandated report came from a teacher or from a police officer or a family friend. Things are pretty similar across those sorts of characteristics. We find similar results using the non-parametric bounds that I was mentioning before, not doing this sort of extrapolation. We have a model in the paper buried in the appendix somewhere, sort of trying to understand whether this is coming from racial bias or statistical discrimination or indirect discrimination. It seems to be coming from racial bias. And then we have an analysis which has actually been now spun out into another paper where we have data not just in Michigan, but across all other, many of the other US states. We don't have the full sort of degree of randomization in those data that we do in Michigan, but we can still apply some of the sort of non-parametric bounds to state-specific disparities in different CPS systems, and things seem relatively stable across that. So it's not just, the results here don't seem to be just about Michigan, they seem to be relatively externally valid. So let me wrap up, and then there's a couple of minutes left. We can take any other questions. So what, for this conference, what is the sort of main takeaway here from this analysis? I think it's that we have now these tools which let us study a particular form of discrimination, unwarranted disparities, in multi-phase systems while avoiding omitted variable bias. And the key ingredients for doing that is data that lets us look at individuals as they move through a system across different decision makers. And crucially, we have some quasi-random or idiosyncratic variation in the assignment of decision makers who vary in the decisions that they make. And those two ingredients let us sort of study the systems-based approach to discrimination, which historically has been kind of hard to bring to data. And so, as I mentioned before, other settings where we're thinking about applying these kinds of tools, criminal justice is a big one, healthcare is a big one, education is a big one, labor markets, hiring decisions. And then, I'm very interested in sort of algorithmic bias, or algorithmic discrimination. I told you that the unwarranted disparity measure we're using here is very closely related to some in that literature. And so you could imagine mapping this also onto things in those literature where you have a system of, say, a human and an algorithm making decisions jointly, or maybe different algorithms making sort of decisions across different data collection systems and so forth. So I'm very happy to talk offline after the conference or by email or in other ways with anyone who wants to think about maybe applying these in different settings, particularly if you have some cool data to do it in. Substantively, if you're interested in child protection, as I am, I think we find some interesting results here. So, we find some nuance, I think, to ongoing policy discussions in the child protection space. And I think what the child protection application highlights is really when this approach is going to work well. It's going to work well when we have relatively low treatment rates or relatively small selection issues, such that we can do that extrapolation or form those bounds and get kind of informative estimates that we buy. And so let me just wrap up there. Thank you so much for your attention.